Now these concurrent models, what they do is they allow to represent iterative and concurrent elements of process models. So if you see, we have mentioned something called as parallel process model, okay? Parallel process flows. Okay? So we have iterative process flow, we have parallel process flow. So whether we have possibility of making certain things parallel, concurrent, we try to make those things. Okay. So this model specifically allows you both the things, iterative as well as concurrent. So whichever are iterative and concurrent, that's where you can plan for doing some activities parallelly, concurrently. Okay. So example is mentioned. Accomplish the modeling activity defined for the spiral model by invoking one or more of the following software engineering actions like prototyping, analysis, and design. Okay. So what you're doing is you're doing modeling activity in a spiral model. So spiral model it's in one of the iterations. So modeling activity of spiral model you are performing, and in that it's defined for the spiral model by invoking the prototyping model, or prototyping, analysis, or design model as well. So anything you can use. So modeling activity is being performed. However, it is being performed using prototyping model. So within the modeling activity, you are having a prototyping model. So that's how it combines two or more models together and allows you to perform some activities of the project or software parallelly or concurrently. Okay. So it defines a series of events that will trigger transitions from state to state, because you need to have, when it's a concurrent activity together is happening, you need to define that, okay, these two actions are finished, then we can go for the next actions. Okay. So if there are two actions happening parallelly, concurrently, and the next event requires these two to be finished, and then only the next can start. So we can provide that kind of a state. Okay. So on completion of this activity A and activity B, we can go for activity C. Then activity C is complete. On completion of activity C, we can start parallelly activity D and activity E. So that way you can provide events, okay, that will trigger the transitions from state to state to perform some kind of actions. It is applicable to all types of software development and provides an accurate picture of the current state of the project. So this model, obviously, when you say we are going from state to state, so you know that if my communication activity is over, only when communication activity is over, you can go for planning. Okay. So there will be an event. Okay. Communication activity over, start planning phase. Okay. So now I know that my earlier activity is done. I can go for the next activity. Or we can say in prototyping, first prototype is being built. And prototype is being built, that means it's under functioning. Once you say prototype is complete, so my action is done, I can go for the next step. So that's where you know that these activities are being performed and being where exactly I am in the project development cycle. So for this, generally what is being used is called as process diagram. Okay. Process network is used to represent what is the current state of the current state of my system or current state of my product. So that diagram presents you, or it's called as process network diagram, or it's also called as PND, process network diagram. Yes, PND or process network. Okay? Anything can be said. So in this, if you see this diagram, so this is explained for a modeling activity. So within the modeling, what you are doing is modeling is part of your spiral model. However, within the modeling, you are performing these various activities which may be performed by using a prototyping model also. Okay? So what you see is each activity, action, and task on the network exists simultaneously with other activities, actions, and tasks. So each activity, action, and task on network exist simultaneously with other activities, actions, and tasks. That's when we call them as a concurrent activities or parallelly being performed. Events generated at one point in the process network trigger transitions among the states. So like we say, it's under development. So there is something called inactive. So this is a under development state. It represents the state of software engineering activity or task under development. It's not done. Okay. So once you say it's being done, I will have this part. Okay. So this is the case which represents. Okay, now it's being done. Within which what will happen is, now one will say you're avoiding changes. Okay. Why it's under development? Because we are waiting for some changes. Okay? Or it may be under review. Okay? Now that's where we are saying this action, this modeling activity that is being performed, why it's in prototyping phase? Because either prototyping phase, because you have made a prototype, but it's under review. Okay? Now when it's under review, some other activity might have been performed, okay? Or going on simultaneously. Some other model is being built simultaneously. Okay? So you can have two different models being built. So when one activity is under review, other activity is simultaneously being developed also. That can also happen. Okay? So if it's under review, then it will be checked for benchmarks, okay? Whether it is following some kind of a standards or not. If it follows the standards, then it's done. If it's awaiting for the changes, okay, then once the changes are or whether to add the changes or not, you can provide for the revision, okay, under revision. So software or model is under revision. Okay? So model is under revision. That means it is to accept some kind of a changes, and to accept the changes, it has to identify where are the changes, what these changes will what are the exact changes, how these changes will affect the other components in the model. Okay? Are there any repercussions or other functions if this change is adopted? Okay? So you do the revision, put it under review, again check against the baseline, and you have added. Either you say you add the changes or you say no, changes will not be accepted. Otherwise, in both the cases, if you say once this is done, it goes for awaiting changes, because it's an activity which will keep on happening. As we have mentioned, that changes will keep on coming. And for modeling also, till the time the model is not complete, we keep on building prototypes of the model. Till the time our model is not complete or acceptable, we keep on creating various prototypes for the same software or for same model. So in that case, these activities will keep on happening, and once it is done, we go for the next state. So from inactive to active, you can say. So once it is done and no more changes are required, my modeling activity is over, my prototype is complete, and now the prototype is acceptable. So that means the model is acceptable. I will go for the next activity in my cycle or process in that case. So that's a concurrent model. Then we have something called as unified process. This is another process model. This is developed or presented by Jacobson, Buch, and Rumbaugh. Okay? There are three software scientists. So we call them software professionals or software scientists. Okay? So like we are scientists in every discipline, we are scientists in software discipline too. We call them a software scientist. Okay? So they developed this unified process model. Okay? You better know it as a UML. Okay? I hope you must have heard a term called as unified modeling language, or use case diagram, class diagram, deployment diagram, then state diagram. So this activity diagram. So you have heard at least these names, I suppose. So these are the diagrams, or these are the models which are built in this unified process model. Okay. So it emphasizes the need for a use case driven, architecture centric, iterative and incremental software process. Okay. So you see what it does. It's first use case driven. What is the meaning of use case? Use case is a function. So for every function, we draw a use case diagram. Okay. So when the functions are done, that means you identify all the functions. So once you identify all the functions, then you can go for the next activity. That is, when you merge these things together, what will happen? So when you merge this, say two or more functions together, or you club them together, then can we merge them together? Can they interact? So we merge all the functions, or sorry, instead of saying merging, we bring together all the functions which have some kind of an interaction. So like say now output of one process or output of one function is input for the next function. So in that case, though these are standalone functions, there is some kind of interaction between these functions. We bring them together so that we can build a say component. That component can be called as a class in that case. Okay. So from the functions, from the use cases, we can get a class. Now when you have classes, as soon as we have a class, and you can identify how the classes will interact with each other, you will find that there is some kind of architecture developed. Okay. We'll see that there is, yes, we can see some kind of architecture. Okay. So it's architecture centric also. So there are various architectures. We'll see subsequently, or I will at least mention subsequently that there are some architectures. Okay. So there are some architectures for software too. So like we have mentioned, layered architectures can be present. So or prototyping architectures can be present. So various architectures are there, which are part of software design and architecture. Okay. There is separate subject to study the architectures called as software design and architectures. Okay. So in which various architectures are mentioned. Okay. So this unified process model is architecture centric. It's iterative and incremental. So obviously it's not going to build the entire software in a single as a single product, because as you see that now why this has been developed, this is being developed recently. Recently means around say last 10 years, 15 years it is there. Why it has been developed? Because there is a need to have a process model which can be used for building larger projects, complex projects. And whenever you're having large and complex projects, we don't build it as a single product. Okay, we divide into multiple components or modules. Okay, so you know that there's something called as top down and bottom up modeling is there. Okay, so if it's a top down, it's a top down approach is there. We have a big software project which you break into multiple components, or small or bigger components. And those components are then subsequently broken down into say a smaller components. So each component will have the subcomponents. For the subcomponents, then we look for some task, and within the task we'll have some functions. So we break down the entire project into small functions which are manageable. Okay, which are easily understandable, and at the same time we know that there is some kind of interfacing which you can provide for these two or more functionalities together. Okay. So in that case, this kind of a unified process model is quite useful. Okay? And obviously, as a software, you want to have more complex or sophisticated softwares. You want to have more things to handle. Obviously, you need more things or more software engineering processes to handle in that case. So to make this, or we can say one sense to make life easier, this unified processing model focuses on functions. So if you know all the functions, like after requirement analysis, you go to identify all the functions in my system. So that thus function becomes your use case. So it will be driven by all the functions in your system. That becomes more manageable in that case, more understandable for users too. Okay. And then for this, what they called is they build a language called as Unified Modeling Language, or UML. Okay, so it's a technology to support object-oriented development, but did not provide the process framework for application technology. So that time people they only this one of some of these authors with others, they work on the UML. They developed the UML language. So UML was being used specifically if you see for OA, because when I mentioned class diagrams, as soon as the classes comes, we know that there is something called as object-oriented programming, because classes will create objects. Okay, from classes we are having the objects. So once we have that thing, so UML is specifically can be said for object-oriented programming, or OOP. This was there, but what was not present was the process framework for applying this technology or this language. So in that case, they developed then this is what is called as unified process model. Okay, so hence the unified process model was developed with phases as inception, elaboration, construction, transition, and production. These 5 phases were mentioned, and obviously we'll have a diagram for this. These are the phases which are mapped to generic framework activities. Okay, these are not something new. Like you say, inception phase is there, which is similar to our communication and planning framework activities. Okay. So in framework activities, we have these five activities: communication, planning, modeling, construction, and deployment are the 5 framework activities. Now with new terms of unified process model, which we say as inception, elaboration, construction, and transition, these are mapped, or this can be mapped to our these phases. Okay, phases of our framework activities. Now in this, if you see, the communication phase and planning phase are part of inception. Now, what basically you can do in this two is, obviously inception means you are trying to understand what the problem is. So understand the concepts, understand the problem, understand requirements, understand what kind of a solution it can be built. So we have mentioned that before building a solution, one should understand the problem. So that's what is being done in inception phase. Then you can go for planning and modeling. So planning and modeling is elaboration. Elaboration has you may say that in every activities there are two. Apart from construction, all four other activities, if you see, three activities, if you see, they are related to two phases of framework activities. Like elaboration is related to planning and modeling. So there it elaborates the plan. Within the inception, you identified that yes, we may require this much amount of a time. Now in the elaboration phase, you can identify for every activity how much time is required. Every activity says for every function you can identify which will require this much amount of time. So based on which we'll say will require this much amount of cost. Okay? So all those costing and the time duration can be identified or can be elaborated for the planning phase in the elaboration phase. Okay? In the inception, you just identified, okay, will take 2 years. But how these 2 years will be divided over a period of say every week, every month, what are the deliverables? So that you can provide in the elaborate planning. Then elaborate modeling can be performed. Elaboration modeling. So whatever requirements you understood, elaborate those requirements in the form of a model. You create the models for problem as well as solution both. Create the models and present that this is how we have understood the problem. Do you agree with this? If the customer says, okay, this is how the problem looks like, or so, your solution should be, then you can go ahead with the next phase. This is construction. Okay. So you do the construction as implementation of your model. And when there is a transition is from construction to deployment. It's called as transition. Now, what is happening here is if you see that in the construction you are building the first prototype or first increment is being built there with the core functionalities. Okay. So that will be tested. That will be given to the customer. So transition phase is testing by the software development team as well as the customer side also. So both the teams, both parties are testing and providing the feedback. So construction is being done at the development side also. At the customer side, they just do something called as black box testing, you can say, or functional testing they will perform. So they will test their functions based on the requirements. Okay. Now, once this is done, deployment, after deployment, what you see is first release is ready. That we call as the production phase. Production means once your first increment is there, you can just use it. You can start using it. Okay, like the way you are seeing all these software that are available nowadays. So you have say a version is there. So that version, once it is available, we all can use this version. Like right now we are using this Teams version. So this is version 1.03, something like that. Okay. Now everybody can just use. It's a production phase. We can just download and use it. So 1.03 is being used now because it's just released in July 2020. Now after say 15 days or 20 days, there may come up a next increment with refinement with additional functionalities. Okay. Like right now, in earlier it was attendance was not there. Attendance is added. So we are now download attendance. Now subsequently, they added the class notes and assignments to this. The entire process of assignments. That was the next increment. Now subsequently they will be providing these facilities. Like right now, if you use the web-based app, it doesn't have a facility of using the background. However, the desktop app has the facility of using the background. Now there are two different products in that case. So the products which is web-based product app is there. So there they can add this increment subsequently. Okay. So likewise, these increments will be added. And we have that stable working version available with us. Okay? That's what we generally say. Stable versions are there. Same applies for your this operating systems too. Like we are having Ubuntu 16.04, Ubuntu 18, Ubuntu 20. We look for a stable version. So once a stable version is there, it can be reproduced. It can be produced. It can be just downloaded and used. Okay, that's why we say the production phase. However, this is not similar to your manufacturing. Remember, because we mentioned that it's not a manufacturing. We are engineering a software. We are developing a software. So this will keep on changing. We keep on modifying the software in that case. Okay? So this will happen in incremental fashion in that case. Okay? So That's how this will be used as a concurrent processing or unified processing model. Sorry. So today we have seen